Hi friends, welcome back to Hobby Plus. Today I will discuss about a Snubber circuit. First of all, we have to understand why we need this circuit in power transfer circuit. See, if I don't put here, this is your Snubber circuit. If I don't use this circuit in this power transfer circuit, you get a trouble. Now see which type of trouble you can get from this circuit. That is your oscilloscopic output. Here is a pulse, come here and goes there to here, but there is a ringing. That is your ringing part. You get this ringing with pulse output of the transformer. You just get this pulse in that point, and also that point. Why it is happen? Because here is a inductor and here is a capacitor. That is not a physically connected in this circuit. That is a virtual capacitance of this MOSFET. Source to drain, that is your source point, that is your drain point. So source to drain capacitor is, this is source to drain capacitor. So this coil and this capacitor automatically resonate and make this ringing. That is also called magnetic interfacing, electromagnetic interference. So you get here and your high frequency diode cannot protect this frequency, so it will be blow off. Your external appliance also break down for this. This MOSFET also goes breakdown for this high frequency and your coil also. There is a three part. One, protect your MOSFET. Second, protect your inductor. Third, protect your Schottky diode or high frequency diode and your external appliance. Now I tell you how it is work and why it is attached here. Here is a 310 volt DC supply. Your drain also get this, because it is a coil, you can get this. When pulse appear on the gate and MOSFET goes to on, then this inductor build the energy. So you get here your supply voltage into 2, that means 620 volt, but your switch source drain breakdown voltage is suppose 800 or 1000 volt, but the ringing peak, that is called peak. I should show you again this picture. That is the peak. I think you see this. That is your peak. It is more than 100 times. So you get here more than 100 times volt. So this transistor goes to be blow off. MOSFET, IGBT, all are transistor, you know. Silicon switch goes to be off, permanently damaged. So you have nothing to do if you don't use this circuit here. Now I discuss how this circuit is work. Here is the, when it is charged, here is a 620 volt DC and a high peak. So if it is not, suppose 620 volt DC and it is your 310 volt, that means a voltage go through this path and through resistance back to the main supply. Why? Because that is 620 volt and that is 310 volt. So voltage can go through this way. But here is a resistance who can protect this voltage, and it is a opposite angle, so your power supply cannot through this way, but when it is come here it goes to this way. But when the MOSFET is on, then total voltage goes to ground through this MOSFET. I think you understand that. So no voltage goes to this way because that is a short path, so this voltage goes to this way. But when it is off, then here is a high voltage due to resonate coil and capacitor resonance, a high peak. So high peak through this diode, through this resistance, goes back to opposite end and make it neutral. Secondary, a primary coil makes to neutral. So you don't get any ringing from this point. That is a Snubber circuit. That is a clamping circuit also. You can control this through this circuit, damage to protect, damage this coil, damage this silicon switch, damage this diode. You can protect it. It is a little difficult circuit. Today I am not going to discuss how to calculate this snubber. I will tell you later in my next video. But you always remember that you have three necessary damage protection circuit. That is your three necessary damage protection circuit. One is inductor coil, another is MOSFET, another is Schottky diode or rectifier. I think it is more than enough to understand. If you not, please tell me in my comment box. If you think no, there is some problem, you also told me that in my comment box. I know you know that what to do after all these things. Please do this. It is motivate me to make next video. Thank you for watching.